Inverses undo each other. We looked at them in tables, in graphs. We talked about how they reflect across the line y equals x. We said that for a function to have an inverse, it has to pass the horizontal line test, or you would have to restrict the domain like we did here in A. And did we mention up here? We talked about algebraically the way to check for an inverse as well is to replace f of x with y, switch the x and y, and solve for y, and that gives you the inverse equation. And then we had the rule up here that talked about if these functions are inverses, then this would be true. So on the back, you were supposed to have tried the check for understanding. So the first one was a table. You were asked to find the inverse of g of 12. So how you should have thought through that, or a way you could have thought through that, would be to realize if this is the input, right, of the inverse, it was the output of the original, right? Does that make sense? That's the relationship. Okay, so here's the original function in the table. So again, what I'm saying is if g of x is going to have some point, okay, and if the input of the inverse is 12, for the original, the output was 12. Does that make sense? Because they switch. Okay, so then we go back in the table and we look, okay, in g of x, where was 12 the y value? And that would have been here. Okay, so 16, 12 was the point on the original function. So 12, 16 is on the inverse. So our answer here is 16. Do you follow? You didn't have to show this work. I was just putting that to try and explain that, what I was saying. Now we're doing the same thing in 2, except with a graph instead of a table, but the thought process is still the same. Okay, we want to know, okay, what is the inverse of h of 2? So that means on the original h of x, 2 was the output. Okay, so we're going to look at the graph. The graph is of h of x. Where is the y, 2? It's here. So here's the point on the graph, and that's at 5. So the point on the original is 5, 2. So on the inverse, it would be 2, 5. Everybody good with those first two? So that's understanding the relationship that the points are switched from a function and its inverse. Everybody good? All right, now on number 3, I think this was probably going to be the most missed for those who tried all 5 of the check for understanding, just because we are given the meanings of our variables here. We're told that they're representing Celsius and Fahrenheit degree temperatures. They're not just an X and a Y, okay? They actually represent something, okay? So there's 2 ways you could think through this problem. You could say, okay, I understand that in this problem, okay, the way that this is written, we would consider we're converting from, we know Fahrenheit, we're trying to find Celsius. That would make Fahrenheit the X value, or the independent variable, and Celsius would be the Y, the dependent. Does everybody agree on that, the way that the equation is written? Okay, so if we're going to set it up that way, I'm going to replace that with Y and X. And then if I want the inverse, what do I do with that Y and X? I switch them. And then what do I do? Okay, and then I solve for Y. Okay, so to solve for Y, what would I do here? Multiply by what? By 9/5. Okay, so multiply by 9/5, or if you want to write, if you wrote that as dividing by 5/9, that's fine, but that's the same as multiplying by 9/5, because that way the 9 cancels and the 5 cancels. Okay, so we have 9/5 x equal to y minus 32. And what do I do from there? Okay, so add the 32 to the other side. Okay, so we end up with the inverse of y is 9/5 x plus 32. Now, I want to write that with Celsius and Fahrenheit. The thing that gets confusing, though, is in the original function, Fahrenheit was the x and Celsius was the y. But in the inverse function, you switch meanings. Okay, so inverse going to switch meanings. So the inverse of y is no longer Celsius. This is now Fahrenheit. Oops, I started to write the x. Okay, and x is no longer Fahrenheit. It is now Celsius. So this is the equation that you would use then to do what? Yeah, to convert in reverse. Instead of knowing Fahrenheit and converting to Celsius, this would be knowing Celsius and converting to Fahrenheit. Does that make sense? Okay, so when it says, what does this represent? That's what I'm going to put. I'm going to put, this is the equation to convert from Celsius to Fahrenheit. Now, when I said there's multiple ways to think of this, because sometimes that can be confusing, people forget that the meanings also are inverted. You could just solve, since they're already set, the meanings are already set. The alternate is to instead of switching x and y and solving and switching the meanings, you could just solve the equation for the other variable. So if I were to solve this for f, wouldn't I do the same thing I had done over here? I would multiply the 9/5 over and then add the 32, right? So I would end up with 9/5 Celsius plus 32. Isn't that the same equation I came up with? Okay, so you could think of it that way. Understand that inverse relationship of Fahrenheit to Celsius would be Celsius to Fahrenheit. Good? All right. Next up was you were given a function f of x, gives the distance in miles that an ambulance can travel within X minutes of receiving an emergency phone call. So f of x, or y, is the distance in miles, and x is the time in minutes, okay, for the original function. It asks us to interpret the meaning of the inverse of f of 26 being 20. Okay, so what does that mean in the context of this problem? Okay, well, if they're inverted, instead of y being miles, isn't x now miles for the inverse? Okay, so the input now is miles. Okay, and instead of X being the time, now the Y, the output is the time in minutes. Okay, so in the context of this problem, I would say that it takes 20 minutes or 20 minutes pass by the time the ambulance has gone 26 miles. 20 minutes for the ambulance to go 26 miles. Does that make sense? That's a little jumbled over here. I'm going to move this over to the other side so it's not so crowded there. Here we go. Everybody okay with that? Does that make sense? All right, and then last but not least, you were asked to find the inverse of g of x, this rational equation. And then you were asked in part B to check, to confirm that they're inverses using compositions. Okay, so do y'all remember compositions from Algebra 2? Okay, that's what we're going to be doing next. That's our next lesson, is going back into review composition functions. Okay, so this is kind of leading into that. So here on A, if you were going to just find the inverse, I would have replaced g of x with y. Okay, call that my y. And then I'm going to switch them. So I'm going to say, okay, x equals 1 over y plus 2. Okay, and then I can solve that for y. So to solve that for y, what would you do first? I need to get that y out of the denominator, right? Okay, and it's the entire denominator is kind of that expression will have to come out together, right? Because it's that plus 2 is attached to the y. How could I get this y plus 2 out of the denominator? Yeah, so if I multiply by y plus 2 on both sides, that would work. But then I would have the x and the y over on the same side. How would I get rid of the x? So what ends up happening is these two pieces, don't they just end up switching spots? Okay, so I'm just going to jump to that step. If you need to write individually those steps in between, you can. Okay, but I'm going to go straight to y plus 2 would be 1 over x. And then what's left to do? Yeah, just subtract the 2 over to the other side. Okay, so my inverse function ends up being 1 over x minus 2. Are we okay with part A? Okay. Now, you said you remembered compositions, or some of you did. Okay, remember composition is inputting one function into the other. Okay, so that's what it says in the hint here. So you can input the inverse into the original, or you can input the original into the inverse. Either way, if these are indeed inverses, both of those would simplify and reduce to just x, because the inverses undo each other, right? Does that make sense? So I'm going to show both ways. So first, I'm going to take the inverse, which is what we have right here, and I'm going to plug it in right there to the original. So I'm going to have 1 over, and then instead of x, I'm going to have this entire inverse function. Oh, it's minus, not plus, sorry. Minus 2. Okay, and then there's still the +2 in the denominator. Okay, so I input in the original. So this is the g of the inverse of g of x. Okay, now nothing to simplify in the parentheses, so I can drop them, right? So what ends up happening to the 2's? Those end up canceling out. So now I'm just at 1 over x. Okay, and when you have a fraction in the denominator, can't you just multiply by the reciprocal, flip it to get it out of the denominator? Okay, so instead of dividing by 1 over x, that's multiplying by x, and 1 times x is simply x. Okay, because I'll show that I flipped that to just be x over 1 and be multiplying instead to get rid of it down here. And so 1 times x is simply x. So that checks out, doesn't it? We were supposed to get x. Okay, now I'm going to check in reverse. What if I have the original as the input in the composition function? So if that's the case, I'm inputting the original, which is this entire thing, 1 over x plus 2. I'm going to plug in just right here for the x. Okay, so the equation is 1 over, and I'm replacing that denominator x with 1 over x plus 2. Okay, so that got substituted in right there. Okay, so to simplify this, I would do the same thing I did over here to get the fraction out of the denominator. I'm going to, instead of dividing by the fraction, I'm going to change it to multiplying by the reciprocal. So if I do that, 1 over x plus 2 becomes just x plus 2, right? Okay, and then that's still just multiplying by 1 that's in the numerator. And then I have the minus 2. So what ends up happening is that's just x plus 2. And I have the minus 2. And what happens to those? That cancels, that's 0. So I'm again left with simply x, which is good because I was trying to prove that those were inverses, and they are. It checks out both ways. You okay with that? All right. So then we are going to do, that's the end of the notes on inverses, the inverse review. You're going to have a Delta Math practice assignment on inverses.